Hello, everyone, and welcome to another VES-Artex Academy webinar. Today, we are joined by Dr. Mike Wolf, who's a consulting veterinarian for VES-Artex, and he's going to be presenting on ventilation in the off-season with us today. And before we go ahead and get started, just one quick housekeeping item. We will be taking questions throughout the presentation, so if you have a question for Dr. Wolf, please type it into the Q&A in the bottom of your screen, and we will address them at the end of the presentation. So with that, the floor is yours, Dr. Wolf.
Well, good morning to all. Thanks for joining us today. And I'm taking a little different slant on things today. We talk a lot about heat stress and how we ventilate barns under all those varying conditions and barn designs. But today we're going to take a little different focus here and just talk about off-season ventilation strategies and some complications or challenges on different types of barns. So that's what we're going to kind of focus on here today as we walk through different ideas on how to ventilate during the off-season and also talk about maintenance and things like that. So so again, today our focus on the off-season, we want to still remain sure that we're providing fresh air into the building and that's properly distributed through the facilities, and especially in colder climates like we are in the upper Midwest here through the upper tier states here where we may have some freezing conditions, of how we can help avoid freezing up of beds and alleyways with freezing of manure. And a part of it is controlling dew points within the barn, that we had hoped that we can control our humidity levels, that we are at least above the dew point so we don't get dampness and humidity and dripping and things like that going on in the facility that adds to both discomfort for cows as well as people working within them. And then we're targeting here for air quality, the old litmus test here for air quality or canary in the coal mine is ammonia is our kind of like our target gas. And we want less than 25 parts per million for adult facilities during any time during the year, but particularly in the winter when we have higher risk, as well as with calves, we want to be below that 5 parts per million for calves. And again, how we put all these pieces together to make it work for the entire animal environment. So again, we're back with natural ventilation. Old Mother Nature, she doesn't play fair in terms of where she's blowing from and how intense and how long and how the barn is oriented, how other features around the facility are going to impact how well it's going to naturally ventilate. And so again, those are part of the challenge when we rely just on natural ventilation. And again, how these facilities have become more closed in with buildings around them, that natural ventilation that may have worked well a few years back is not working so well anymore. This is a facility that here's the wind is coming from this direction into this heifer facility. And so you think this is quite well ventilated. And this was in December when I was on this dairy. And as you look where these calves are, there's a lot of ill calves respiratory issues in this particular barn. And they got the back curtain, pulled up so the wind can't blow through. But if you look closer, there's no bedding for these animals at all to nest into. So even these post-wean calves have a need to have some sort of thermal break between themselves and the ground. And in this case, this barn, I asked if they had just recently cleaned it, and they said, we haven't cleaned that barn in 3 years because the prevailing winds get so strong in this environment they're in. It actually blows the manure out of the building during the summer months. And so they have very little incentive because that adds more work if they were to put bedding in this facility, and that would help make these calves be much healthier if they would provide that. So sometimes the bigger question is, anyway, apologize for that. I thought I had that on airplane mode. Anyway, so yeah, that sometimes you got to think about what's causing the underlying issue here. Here's some calves in another facility, and I'm sure they probably just bedded this pen because they knew I was coming that day, but there's only about a 10-foot width back there, and these calves are just piled up on that bedding. And I asked the herdsman there, what he sees there, and I said that the calves are telling you something. They like this. They like to have some bedding get them up off that cold concrete. So these are all issues that can add to reducing animal health, because they're diverting a lot of energy toward just keeping warm, and the immune system suffers as a consequence. So these are going into positive pressure tube ventilation recommendations, and these are the recommendations from the Dairyland Initiative, covering both the recommended volumes of barn per calf, the cubic feet of barn, as well as the air exchange rates recommended from the winter through summer, and also the cubic feet per minute that we want for these pre-wean calves in these facilities, both pre and post weaning. So these are just some notes, and you can find these on the Dairyland Initiative, or you can come back to this site here if you'd like to use this as a reference on how you're designing things. So here's a nice, two-row sort of calf barn with a tube system in it, and if these tubes are put together correctly with the right balance of tube size and hole size, and get that air directed down into the calf zone here, these can be a decent supplement. The downside is you can't vary these fans on these tubes. They're set up for one air exchange that you design it for, whether it's 4, 6, 8, whichever. And the other is the fan size has to be able to stand up to the static pressure that's being designed for. So these are something, and we'll address that here shortly as we go into. Here's some facilities where we've had failures, and this particular barn, starting at the top right-hand corner here, the intake housing has a hole put in it so he could recirculate air back through the barn. So now he's, instead of getting rid of the humidity in the building, he's adding more by pulling air back in, and he's thinking that's helping to temper his air, but it's actually just causing more humidity to be kept inside the barn. That barn fan also has a shutter on it, which does reduce that fan's capability to inflate this tube. As you see in the next picture to the right, the tube has a kink in it because it's not stretched out like it should be. And so that's going to create a problem for any part of the tube that's to the right of that kink. As you can see in the lower left, the humidity is actually built up on this tube, and you can see from the vector coming out of that tube, actually the direction that air is being directed, and it's actually more of a tangential airflow out of that hole instead of being directed more down to the animal. And ultimately, the reason that this barn is having additional problems, that on the lower right-hand corner, that's a ceiling vent, and they were totally inadequate for the size of the barn, number of calves in this building. That entire ridge row should have been opened with a cap on it, and they did correct that, and it made this barn, with these other minor corrections, work great after they did that. So it's not only about how we're pushing air into the barn, but we have to have it for air to get out of the building also in an effective manner. Our next slide here is just a video that's looking at smoking. We have the eave inlet where there's air coming in that eave heading for the ridge row, but the tube is actually directing this air back toward the outside wall. And if you look at the bedding in this video, it's more trampled and dirtier toward the feed alley side than it is toward the outside wall. And I always look for that sign as an indication, where are these calves tending to like to lie in that pen? And they were indicating that they didn't like to lie out there toward the outer wall because of this air effect that was a little too aggressive, at the animal level. So these are all little things that can be looked for with the smoking videos as well. What are the calves telling you when you walk into a barn, and how are they lying? Are they evenly distributed in that pen? Or are they tending to be pushed to one way or the other that doesn't really make sense? So those are things just watch for as you evaluate these barns. Here's another barn with a tube that doesn't have enough velocity pressure in it. It's got a high velocity pressure and low static pressure. So the smoke, as it comes in, rushes to the far end of the tube on the far end. And this dairy was making observations that the 6 calves on either side of the fan end were sick. And so they put more bales and plywood around them to protect them. And when I checked with the hot wire, there was no airflow in the beds area for these calves. And when we took away all the barriers, it was still zero. So the first proximal part of this tube was not adequately ventilating this nearer end of the. So we need to increase the static pressure in that tube by either changing the fan size or again, never put a variable speed on a fan because they're not intended to have that. They're set up for a certain static pressure and CFM out of this fan to make it balance correctly. One of the options we could do here is tape some of the holes to kind of increase the static pressure so the more air would come out on the nearer end of that tube. Taking a shutter off here and just put on a hardware cloth to keep birds out would be another option to help that fan perform better, because that shutter will reduce that CFM of that fan about by 10%. And then in this barn, because he was storing bedding at the far end, we said, why don't you put the bedding where the ventilation is poor, and let's put the calves toward the end where that's going to be better. And ultimately, if those measures weren't going to work out for him, we need to provide other options for them with a different tube that's properly designed for that building. So again, I look at drafting airspeed on these animals, and again, calm air in most research studies is less than 80 feet per minute, which is just under a half a meter per second. And I generally find that the calves do quite well if we're between 30 and 60 feet per minute down at the bedding interface. So we have to remember we're not just ventilating the barn, that ultimately our goal is to ventilate where the calf lives in his microclimate. So we want to be sure that we're providing that airflow to cause that air exchange at its level. Using calf jackets help to reduce any drafting potential, as well as reduce that thermal loss, to the air or to bedding, as we were pointing out earlier with those calves that were on concrete. And keeping a bedding score above 2 is another huge impact on reducing that thermal loss and increasing the maintenance on this calf, because we're not providing enough thermal protection. And then in summer, we like to see these airflows over 300 feet per minute so that you can actually see the bedding rustle. And a bit that helps deter flies, as well as help with cooling the calf and drying the bedding. In wintertime, I see issues once we fall below that 30 feet per minute. And to do this, you're going to need a hot wire anemometer to actually measure these lower speeds, because your typical turbine type anemometer is not going to read these lower levels. So that's if you're into much calf analysis, you definitely want to have that sort of a tool to do that evaluation. So let's move on to pressurized tubes in cross-vent barns. So it's something that's being tried, incorporated to try to get some fresh air into these large buildings, especially in the winter times when the ventilation rate slows down and we still have a bit of degree of heat coming off the cows. But a bigger issue is with the gases that are both coming from manure and from feed sources that are giving off VOCs to make that air fresher in the barn, as well as controlling humidity. So those things have been tried. Here's an example here on a cross-vent barn where there's at least 3 tubes in this case. You can see from the outside with the intake hoods on the right, we have the tube actually going down the barn, and these tubes are pushing over 600 feet long. Some of them have fans coming from both ends to help increase that capacity. But one of the issues we see where we need bigger fans, as you can see in this picture here on the left, they've taken this fan that's about a 55 to 60 inch fan, and they're coning it down to probably less than 3 foot. And so when you do that, you're choking that fan's ability to put that air out. And if we look to the right here, this is actually a video from the outside where we measured the intake velocity and across this section here to see how much air was actually going into this barn. The louvers on the right were completely shut, but the louver on the left was open. And because the air was backed up basically in that fan and not able to move through, because that fan is turning as we're looking from behind in a clockwise manner, the air is actually forcing that shutter closed on the right and helping lift the shutter on the left. And when we did the calculation, that fan was only putting out a third of the capacity. It was like a 30,000 CFM fan, and it was only doing 10,000 CFM. So in terms of its effectiveness to add to the air quality in the barn at a normal 4 air changes an hour, it was only providing less than 10% of the actual fresh air coming into that building. So again, this is part of the struggle we're having, and how do we, as we get into these barns over 20 rows, pushing 30 or better, as to how do we ventilate these barns in these certain climates under winter conditions. So this is a recirculating fan internally here. And so what we're doing here is trying to cover the whole calf area. This is actually a tunnel barn, so there are exhaust fans working with this airflow at the same time, but we're gently trying to bring some of this air that's up above that will tend to be warmer and tend to be drier down across the bedding by using this sort of a fan setup to cover that area. And the picture to the right is just another example of a post-wean barn where we also have pressurizing fans bringing fresh air in from the side that will be caught by those recirculating fans and put that pattern down over those beds in this kind of a neutral pressure type barn design. Moving along to other ways of helping to move. Now, these aren't creating air exchange. Any of these recirculating fans are taking the air that's in the barn and redistributing it properly. So in this case, we're using ceiling fans as a common year-round sort of element in many calf barns, and it works quite well when you combine it with exhaust fans that are working at the appropriate exhaust rate. So again, this is just a video. This is more of an aggressive speed here, but you get the idea of how this air, when it comes in through that ceiling vent, will tend to hug that ceiling, and once it gets over into the zone where the fan is, that air is being driven down into the calf zone. And again, these fans are adjusted then to make sure we're not drafting that calf area, but we'll generally mount them about anywhere from 12 to 15 feet apart across the ceiling area, and they work well even with the individual calf stalls as a way of mixing air. But again, it is combined with an exhaust strategy that's appropriate across the different seasons that wherever this barn is located to work correctly. This is a tunnel barn. It's a nice dairy barn converted into a calf barn. And the airflow with the way the barn was set up with exhaust fans works quite well as a tunnel barn. The only problem is on this side that's closer to where the cows stood in the manger area, where the bedded area is, does not work well in the wintertime. And so we're not getting air in that calves microclimate. And as you watch this air, as we put it in with no assistance other than the tunnel vent air, the smoke tends to want to stay high and doesn't really, ventilate down at the calf level. And you'll also see, because of the tunnel air, it's called entrainment. The faster air out here in the alleyway is actually going to pull that air out from the calves and into this center scrape alley, and then head toward the exhaust. So, and you can see how the smoke is staying above the bedding level where that calf is going to be lying a good share of its day, and its nose less than 6 inches off the bed. So here we have put in a 20-inch basket fan with the temperature control and a variable drive on it, so we can attenuate how fast we want that fan to go. And see, now we're driving that air at a gentle speed down across the bed, and you'll see the smoke will tend to stay down at the animal level as it moves up through the barn, and it actually stays out over the pen, and it's not drawn into the alleyway like we saw in the previous video. So setting up this barn with a fan for wintertime, every other pen would effectively move that air through that area for those calves. And for summer, you could add one at each pen that you could run it more aggressively, to help control flies and improve the air quality and dry the bedding during those months. So again, we go to cross vent facilities. Some of the bigger drivers of why we're seeing more of these barns being built is the capital cost, per animal unit. They're getting longer and wider, and natural ventilation is no longer practical in these sort of facilities. So it's all has to be power ventilated. These larger rotary parlors that they can move through cows at less than 4 seconds a stall can account for some rather large pens and still get those cows milked in less than an hour. Again, we're seeing higher stocking densities in barns. And so this whole, along with heat abatement, but also winter management, we're seeing as an issue here as these barns slow down. And how do we get fresh air? And the tube that we saw earlier was an attempt to do that, but it's not entirely effective as a percentage of the fresh air we need. So again, in tunnel and cross vent air, we want to control the fresh air, make sure we're getting that in and get it to the animal level. We want that cooling velocity in the summer. In the wintertime, it's more of an idea that we need to move that air gently, but remove, just like we do with the calves, the humidity and gases that are at the animal level effectively out of their environment. So we usually design those cross vents with prevailing winds at the inlet side, using wind roses and other data for how these barns are situated and the targets that we're using. But when we get down to the winter KPI here, we want to see somewhere in that 80 to 130 CFM per cow. And the air changes are generally not in that 4 air changes an hour because of the heat that's being brought in or created by all the cows in the barn. It's rare that these barns will ever run, at that 4 air changes an hour. They'll generally be running 8 to 16, at least because of the temperature. The only problem is at the inlet, to pull in the air to do that, unless we bring that in correctly, it's going to fall on the floor and tend to cause freeze up on those stalls and alleyways that are closest to the inlet of the cross vent or the wide body tunnel barns. So again, with trouble between baffles is that we have this trapped air that's up above that's represented here with the blue area up above between the baffles. And so that tends to be trapped between baffles. And when we slow the barn down, we have more accumulation of that. So the air quality at the exhaust side of that barn, it will tend to be lower in terms of gases that are going to be in that, as well as the humidity will be higher. And so those are things that are harder to control because we have the baffle in there creating that trapping of that air between. So here's another attempt to in a cross vent barn where they went and drilled holes in the polycarb. So these are 2.5 inch holes. There's 550 of them down in this barn. It's over 1,000 feet long. They're put in 24 inches on center down that ridge opening. But in reality, getting up there and measuring the airspeed coming through the hole and doing just a rough calculation, only 3% of the minimum vent air was actually being delivered into the barn. So it's an honest attempt to try and do something about air quality in these barns when they're slowed down. But we still have the problem that we're not really getting the volume that we need to be really effective. And so it's more of a feel-good attempt, but not an effective attempt here. This is the strategy that's being used that's using some powered baffles along with stationary baffles as another alternative way that we open up so we don't have less apt to have this air trap between the baffles. The recirculating fans help bring that air down, and whether it's summer to create higher velocity like the baffle does, in the winter it's helping to mix this air, and also opens the air in the barn up more aesthetically than when we have baffles in the barn, and helps with lighting designs also are favorable if we have less baffle challenge in the barn. But again, it's adding more fans to the situation, but some people are choosing this option because they're not particularly in love with baffles because they come with their own challenges. So then we come to the crossbred, kind of a hybrid baffle that we were just showing you here. And so this is where we're trying to reduce some of that fall gas because we're mixing more of the air. And so we end up with fewer baffles. We do some of that short circuiting because we're helping air move toward the exhaust fans. And it helps with electrical efficiency and make sure that we're targeting air speeds that are appropriate for in the cow's living space. And like I said, the barn aesthetics that people don't like, the closed-in feel of a lot of baffles in their barns. So then we go to traditional tunnel barns. Again, you got different options here in how we can move air. The baffles in tunnel barns have become less popular and kind of an outdated strategy now that we're primarily using recirculating fans in either a totally negative pressure barn or using some powered inlet that we'll talk about here later in terms of how we get that air through the barn. So it's got some of the similar qualities, but again, it becomes more of a challenge in terms of winter ventilation. The longer we create these barns, that getting barns traditionally, we want to stay less than 600 feet because the air quality, especially when the air exchange is reduced in winter months, can be quite lowered value at the exhaust end by the time you come over that many cows before it's exhausted. So these are some of the problems with tunnel barns, and it can happen with cross fens too, is short circuiting. We can be pulling air, nasty air up out of the manure flumes. If this is open to the outside air, that will be coming through and pulling nasty air into the barn and humidity from the flumes. We'll have short circuiting going to the parlor here in the center picture. That's bleeding in extra humidity into the barn and cutting down the recirculate or the fresh air coming from the barn toward the inlet, which is in this picture on the end toward where the cow is standing is where the inlet would be. So we're robbing some of the ventilation that should be coming down through that section of the barn. And finally, at the lower right, this air coming in that's cold will drop on this floor if it's not coming in high and fast enough, and will cause freezing of the water and this crossover alley, which is not good for cow safety or people for that matter that have to work around these areas. We want that air to come in at a high and fast rate of 800 to 1,000 feet per minute to make sure it mixes with that air up high in the barn before it gets tempered before it comes down to the cow level. So again, the neutral or partial neutral barns is the addition of pressurizing fans along with the exhaust fans, and it can range in just enough fans to satisfy the first three stages until we're out of the cold times when we can start opening up curtains, especially bottom up curtains that may be frozen or tied down into a snowbank. That this is a way of satisfying intake without endangering or having troubles with snow on the outside. And that's generally where using a split curtain helps that, so we can do a top-down curtain to help solve some of that. But the other problem that you have where all your cold air is coming in one area of the barn, that'll tend to drop that temperature enough that you will have some freezing up of beds and alleyways, and using the pressurizing fan as a way to distribute that fresh air, cold air that's coming into that barn down the barn, so there's plenty of heat coming off cows for that to get tempered before it's brought down. We still get the same fresh air coming into the building, but we're tempering how it's getting in, and as the barns get wider, we can throw it into the building further to help get that fresh air distributed across the whole width of the barn. And then some designs we have where people have chosen, they hate curtains, and so they've chosen to use this as a year-round method, even during the summertime, to ventilate their barns even when it's warm. But it's a huge asset, even at an appropriate staging of your exhaust fans with this is a great way in cold weather to bring fresh air into that barn. And we're finding that we can ventilate barns over 1,200 feet long in Wisconsin one way in the wintertime by using this tactic very effectively, along with recirculating fans in the barn. So we got the fresh air injection strategy. Again, we bring that fresh air in. As I just said about the barn width, we're getting into the barns up to 300 feet wide, and with these fans, we can blow push air into the barn, up to 120 or so feet from both sides. And so that helps get that fresh air in the middle, combined with some fans on the gable end wall to push that in. And so, as I just mentioned earlier, that's working quite well. Again, you want to keep that barn floor in particular above freezing, and so that we don't have that freeze up condition. And the staging, like I said, is maybe 4 to 16 air changes an hour that we would use as partial neutral design. And again, also helps with the exhaust by keeping that static pressure low so they can run more efficiently by basically pushing in the air instead of having to pull it through an opening. And that's where one of the challenges come on these cross vent barns. We recently did last spring an evaluation on a large dairy that was having issues with fogging in their barn around the connecting link that went to the parlor, as well as fog was going out their inlet of the barn. And we start to look at how they had their fans set up. They were running a set of like 55-inch fans at about 25 to 30% of capacity toward the north. And so what was happening, these fans, even though they're turning, they're not effectively moving air out of the building because of the headwinds they were facing. And so the air was, from the intake side, was actually turning in the barn and going out the higher point, back out the inlet. And so what we recommended they do is they had to put shutters on every other fan and double the RPM, or the capacity of the fans that were running. And so then when we create the proper exchange to be able to stand up to that headwind, you generally need to be above 50 to 60% on that fan's operating speed, actually handle a headwind and still be effective at ventilating the barn. And the other issue, that the minimum inlet was too large. So even if we did correct how many fans were running, the inlet was still double what it should be, so that we get that air coming in when it's cold at that 800 to 1,000 feet per minute. And that's one of the advantages of using the pressurizing fans, especially in these tunnel barns. It's a little more of a challenge to look at this with these big cross vents, but we eliminate that using static pressure to bring that air in the barn, because it can be quite variable as to how well that's going to work. So just some things that we're seeing in the field, and how we can handle some of these challenges that just in terms of in that dairy in particular, they didn't have to buy any more fans or anything. It was more that the original design that was done by someone wasn't really addressing those issues. Just because the fan is turning does not mean it's effectively moving air. Here's an example of in Europe, where we're using fresh air injection to bring some fresh air into these barns, and a lot of these barns are built with very shallow ridge row, so they don't really have a natural peak to them, and so they're less than that 312 pitch, and so we're forcing some air into the building, and then we're pushing it down to the animals with the recirculating fans, and then the air leaves the barn whichever way it can. As you can see, there's lots of places with the space boarding or open-ended, because these barns are not cold enough that they really need to tighten them up like we would in more colder climates that we experience here in parts of the States. Here's another example, more of a coolish type climate, that to help these barns ventilate better, that we're actually pushing fresh air in at areas down the barn. We still have an open eave up here for it to naturally ventilate. The cows are being fed from the outside. So these barns don't lend themselves to be turned into really a tunnel barn situation, but we can still effectively bring fresh air in, even in the cooler months, and then redistribute it to the cows by using the recirculating fans over the beds. So again, we talked about that the winter ventilation, we got the freeze up issues, we got the curtain freezing down, jamming, it's taken out of the picture. And again, getting the gases out in an effective and active manner is really important. And this, stops that short circuiting that I was mentioning earlier about pulling air out of manure flumes and from other areas. If the air we're exhausting equals what we're pushing in, you won't be pulling air from other areas that you really don't want air coming from into your facility. this is just a schematic of that setup. So we're again, the target is we're ventilating the cow, not just the building. So we have the exhaust fans to the right, some pressurizing fans to the left. We have the recirculating air fans here to bring that air down to the animal level, but sequentially along. And generally mount these fans about 10 to 12 feet behind the recirculating fan so that this air coming in has a chance to get caught into the intake vortex of the fans and get it delivered down to the animal level. So this, and again, this can be just, like I said, as a partial approach, or it can be where some dairies have gone and as a full year-round approach with no curtains. Here's a video of that working on this barn's about 1,000 feet long, and how we're pushing the air in, it's getting caught by that fan and put down into the animal area. And those cows will lay right in front of that, even in the colder times, again, because their whole thermal neutral area is a whole lot lower than ours is. And so they're not bothered at all by that cooler air coming in and brought down to their level. So some things that have been tried, and chimneys have been part of some natural ventilated barns for years to work with that. And again, there's some attempt to use these in these larger either cross or tunnel vent barns. So this is a barn that it's actually a 22 row wide barn. It has fans on the exhaust end, intake curtains, and with up above, you can see the cupolas coming down in the center of the barn to bring that fresh air in, and primarily targeted toward the winter months. So the deflector on there to make that air go in 4 directions. And this is like a schematic of how that's set up. Again, the exhaust to the right, inlet to the left, and some on the sidewalls. These green fans you see down on both sides of this barn, there's 10 of them on each side, are intended for that fresh air that comes in through the ridge row to be drawn toward the exhaust fans on the side at very minimum coldest times of the year. And as we go into stage 3, then the exhaust fans will start with maybe around 8 or 10 of those running, that then we get a mild tunnel vent flow effect combined with this chimney air both flowing to the outside. And so we did a study there on that dairy and looked at the temperature gradient. So if we look at the schematic A here, that's with the chimney with exhaust fans on the side, and you can see the chimneys are going to be just to the left of this bluer area on the temperature gradient. And we can see how that air that's cooler, and then as it moving laterally towards the exhaust fans where it's yellow, as then B is where that first stage of exhaust fan kicks in. So then we have a little bit of a skewing of that. We still have air flowing toward the sidewall, but we have more warm air coming toward the exhaust fans as that's being pulled up through the barn. The lower schematic here under C is actually the humidity gradient. So as that air comes in, and your air coming in from outside initially is even though it's cold outside, and we think that many times that is higher humidity air because it's cold, it's when you warm it up that the relative humidity drops again as that moves from one side of the barn to the exhaust. We have the same pattern with temperature and humidity, and the same here on D with how the humidity, once we go to stage 2, how that air is starting to move more into a tunnel gradient. So again, it looks like an appropriate way to do this. The biggest question we had, and that we haven't actually tested yet, is what percentage of the air is that we're exhausting through those sidewall fans is actually coming through the chimneys. How much is Mother Nature fighting to pull air out of the building? How much are we short-circuiting from the parlor? How much is coming through the fan wall on the end, especially if there's not shrouds put over the fans that are not running during the winter months, and what's leaking through other parts of the barn, whether it's along the polycarbon. So that's another element that just looking at what is the actual air exchange. But at this point, you know, from the dairyman's perspective, this is working quite well for him. And again, they found that using those recirculating fans, because this barn is sloped toward the middle, that the hot air tended to rise toward the ends, and the they were having trouble with freeze up in the center. By using those recirculating fans year round, bringing that warm air that's up high in the ceiling back down, solved their freeze up problem in the center part of this barn by using that ventilation element as a year round tool and not just a summer velocity fan. So again, let's talk a little bit about fan maintenance. You get any sort of accumulation, and this has been known for long years with the poultry industry as to how much dirt on fans has an effect on their CFM capacity. So again, minimum cleaning twice a year. Again, you start looking at different bedding types, fine sand, manure solid type bedding, that you end up with more flocculent or material. They will tend to get dirtier sooner, and that twice a year may not be adequate enough to keep these fans actually properly working. That again, you're spending the money on the electricity. When those fans are working harder to move the air, they're going to actually use more electricity, and they're actually far less effective. So again, this is a louvered fan here. When I was measuring in this particular barn, that I was going along and I was getting like 600 feet per minute air velocities, and all of a sudden it dropped in half. And I was thinking the equipment was faulty. And then I looked up and saw what it looked like. We cleaned it up, and it brought that airspeed right back up to what we were expecting it to be. So again, a huge factor here in terms of making sure these recirculating fans are cleaned, regularly also. Here's an exhaust fan. And I always like to do this when I can get a chance to get at these fans, is just clean one section of the louvers. So you can see the louvers here to the right and left haven't been cleaned, and the center one here has been cleaned. So you can see how much more that the louver is straight out. These droopy louvers here are going to have a huge impact on the CFM capacity of that fan, and it's going to lose the ability to move air to the design parameter that was originally made up for it. So, and this just taking my hand and just rubbing it off of there just to clean it up some has helped. It's going to improve this fan a lot. So keep in mind that stuff that accumulates slowly, that take a little closer at that as you're walking around your facility, and you maybe should be cleaning them sooner than you think. Here's an example of the dairyman that he invested in a used fire truck, especially after hearing about the fire that happened on a dairy earlier this year. And so he bought a municipal small fire truck that he was able to get his hands on. Well, he realized that he could use this to actually wash. In this case, he's washing his polycarbonate down the side of the barn with the feature on the fan or the truck that will, like for brush fires or grass fires, you drive along and lay down a bunch of water to stop it. And he said he actually takes this and drives by his fan wall while they're running, and he washes his fans and shutters with this, and he can reach on the 6-foot fans, he can reach up 2.5 rows with just this apparatus on his fire truck. And then he can do the top level with just the nozzle directional sprayer that comes off this unit. And to me, it's a kind of a neat way of keeping his truck maintained, that if he ever needs it for a fire, it's going to be ready to go, because he's running it and it's going to have a dead battery or anything like that. And he's actually washing his fans and his barn more frequently. That they do it every 3 to 4 weeks through the summer because it's so easy to do. So this is an example of something that he bought for one purpose that he realized that may be able to help him on a weekly or monthly basis around his dairy routinely. So again, we started looking at our off-season goals. We want to ensure we got ventilation that's appropriate for the season, and that it's in balance so that we're not causing freeze up in the barn, and how we're bringing that fresh air into the building so we don't end up freezing up areas, and we don't have stagnant areas that aren't getting air because we got triangulation. That's another issue that we see in large cross vent barns, where the balancing of the exhaust fans make it so that that there's a wide spread between how the air flows, and so you'll end up with dead triangles as you get closer to the exhaust fans. So it's important how those are put together so that we generally want to see less than 50 feet between those fans on the minimum side, so that at most they're drawn from like 25 feet either way. Helps really reduce that triangulation effect. And then when it gets in your maintenance of the motors that need to be perhaps replaced out, belts and tensioners, and that's what's creating a lot of popularity now with direct drive motors of various kinds, to eliminate that belt and tensioner issue. But those fans also come with their own challenges that are being discovered also with the direct drive motors on these larger fans. So again, make sure you're cleaning all the fan elements, and also don't forget if you got high pressure fog and soaker nozzle maintenance, to make sure those lines are properly winterized, if you want to call it that, as well as getting nozzles switched out and cleaned up so that they're ready to go come next spring, when you're ready to maybe roll into field work or something, and not really a higher priority then. So especially here in the fall before it gets nasty, or in the early spring, to make sure you get at that. So again, my little thought on ventilation here. The propeller is just a big fan in front of the plane to keep the pilot cool, but when it stops, you can actually see the pilot starting to sweat. So apparently that's an important element when you're flying an airplane, that prop keeps going around for you. So I want to thank you all for your attention today, and hope this is worth your time, give you some thinking about your own facility, or if you're recommending for folks things to be watching for to help make sure this investment you're making into ventilation truly get the most value you can out of it for your animals and for your bottom lines. So that's what I got for today. Annie?
All right. Well, thank you so much, Dr. Wolf. We do have a couple of questions that came through. One is, how does snow influence a barn's ventilation strategy?
Well, in terms of whether you're pulling snow in, that's one of the challenges of tubes, or even with the pressurizing fan strategy, that in some cases, depending how that snow is coming at that barn, and the prevailing winds and whatnot, that some dairies, they just shut those elements down, or really slow down the fans, like with the pressurizing fans, that you would slow them down so you're not blowing in as much snow. And for the period, generally it's quite cold during those times, and it lasts for just a few hours at a time where it's most intense, and then you bring it back up again. Same way with the tubes. That's one of the challenges there on both calves and larger facilities, that you can blow a lot of snow into them, and that can make them collapse. So that's an issue. And the others, if you got bottom up curtains, we had a dairy that this summer that someone else had done, and it had no opening at the ridge, and so it couldn't naturally ventilate. And so in the wintertime, when that curtain, because it was a bottom up, was frozen into a snowbank, they couldn't open that curtain up, and you wouldn't want that cold air coming in right at the bed level anyway. And so really, how you put these designs together, you have to really think about across all the season, and not just the summertime, as to how they're going to work in terms of the challenge of climate and snow loads or rain, and how it's being driven in the barns has an effect on the overall strategy and design.
Thank you. Another question, besides decreasing the RPMs for fans in the parlor, do you have any suggestions for ventilating parlors in the winter?
Generally in the winter, the main ones that you're pulling air in, that generally are either off the end or side, is to look at harvesting that warmer air that's over your compressor and pump area, is where we generally try to pull that out of that utility area, and bring that into the barn. And that's going to be warmer, quite a bit drier air that'll help with the humidity in there, as well as to add for all the workers' comfort, using, rather than an air-to-air type heater, you'd be better to use like the infrared sort of radiant heat, because that would warm like the pit or the worker area, whether it's a rotary or a parallel parlor type setup, that you'd warm that area where the workers are, and you don't have to worry so much about where the cows are. And again, bringing that warmer air coming into the parlor really is helpful, and that has to be kind of balanced out for how much air exchange, how much air you got to pull. But the other issue that you can't forget, that into that utility room, you got to be able to have air get into it. So you have to have an inlet of either a shuttered inlet that the static pressure from this fan pushing fresh air into that and warmer air into your parlor needs to be able to provide the inlet so that fan can work. So many times I see where people have that set up, but somebody forgot. They figure, well, they just have a door open or something that they raise an overhead door a bit to let the fresh air in. And there's a lot of times you don't want that sort of opening going on. So making sure you got some sort of either an active inlet where you're actually pushing air into that area, or making a passive where you have a static a louver that will supply the fresh air so that these fans that are pushing air into the parlor can work properly.
Does manure and liquid excrements have a profound effect on a barn's humidity level?
They generally, what we see when we're looking at barns, and again, there's I'm sure there's more detailed research, but just in what we're seeing, that the cows, like in summer months when things evaporate far easier, probably run about 8 to 10% addition. And that's not counting like soaker water or high pressure fog that you may be adding, but just in terms of what the urine and the feces and the breath from the cow. And then this gets all into how those air exchanges are designed to control that not only the temperature of the barn, but also the humidity. In come wintertime, that's more of an issue of getting because the cows will generally warm that air, but we have to remove the humidity out of the barn. Otherwise, you're going to end up with dampness and condensation, and especially on roof elements. Insulation is quite important in more temperate climates. It helps both for radiant heat, in summertime, but also for reducing that condensation. And you get mold growing on those barn elements that either can rust if it's steel, or it's going to, along with the acids and other nasties that are in barn air, as well as starting to eat away at wood members if you have more of a wood structure. So that's why it's important to turn over this air, both for cow comfort as well as maintaining the integrity of the building.
You're looking to build a barn in a temperate climate. What are the top 3 things you'd recommend to keep in mind for year-round ventilation best practices?
Oh, that's a mouthful there. Our tenants start with fresh air. You got to make sure that you have a way to adequately, no matter what the season, you got to be able to get fresh air into the barn. You got to get it to the animal level, and then you got to have the design to get it out of there. And it's generally relying less on Mother Nature to do that for you. And especially if there's any quantity of animals in a building and the size that's going to come with that, it almost necessitates some sort of power ventilation, whether it's just one step up is just the powered, recirculating fan strategy, or it comes more of an enclosed barn. Each one of those has an increased cost, but there's also the benefits, and that's what's driving a lot of barns to be turned into more enclosed in temperate climates. And like I say, now we're showing that we can go beyond 500-600 feet and ventilate barns that are 1,200 feet as a tunnel barn very effectively. And then we get into the larger sizes with the cross fence. Again, there's that whole discussion on where are you going to have this air come in? What are the challenges? Like I explained in that previous example of the barn having some freeze up and air going backwards out of the barn because the fans weren't, they were installed, but they weren't being operated correctly to make the barn work effectively. And so that's where working with people that have a lot of experience in both any type of barn that you're looking at. And that's one of the things that as a crew that the folks here that I work with, we have several people looking over these designs, and it helps to have lots of good heads putting perspective on seeing things. What about this here? What about that? And I think that helps us a lot with coming up with some really good designs, regardless of where it is and regardless of the climate. But temperate climates have their own challenge because we get the extreme at both ends. And so that is definitely something that, because of where we're located, we got very good at that, I think.
Perfect, thank you. Another question, this person was very impressed with the farm that bought their own fire truck and how they found some multi-purpose uses for it. How do you recommend, or what is the proper procedure for washing fans to not harm the motors?
Well, first you need to check what sort of a motor system you got, because some are more open in terms of elements to where the stator and the rotor is, and so you got to be careful you're not blasting a bunch of dirt and water into that. And so in those type of motors, you need to actually put a plastic bag, something over that while you wash that down, and you don't have to use like 3,000 psi type air water pressure to clean these fans up. Put a nice broad spray on it, and wash them down. You can do some dry cleaning, but it's just not as well. In some environments, they're using high pressure air, using an air compressor. Then they can go in, clean these fans off, and they don't have to worry about getting beds wet. If you're talking about any sort of recirculating fan, you're generally gonna have to put a tarp that goes over the stalls, so that area that you're working on, that water that's falling off will drain into the alleyways. And so that makes it imperative to get that sort of cleanup done before our weather turns nastier, which we are right on the cusp here in this neck of the woods of happening. But for sure, by next spring, before you need them, you need to, if you can't get it this fall, to get that done in the spring when things moderate more. And but that's a huge issue. Some motors are more enclosed, and like this barn in particular, the motors that he can drive right by, wash those fans while the motors are running, and he hasn't had any problem with that. So it's a great deal of how the motors are rated, for moisture and protection that way.
Okay, thank you. I think we have time for one more question. If the actual exchange rate is 8 to 16, why does the dairy industry promote 4 air exchanges in the winter?
Well, that's because that's like the bare minimum, but it works well across smaller barn areas. But when you start talking these barns that have 5, 6, pushing 10,000 cows in them, there's a lot of heat coming off these cows. And so you got this balance of both heat and air quality that you need to maintain. And because of these extra bodies, we can run that barn at a higher air exchange rate. But the problem is at the intake, as I was saying, that the cows that are toward that area, if you're bringing in too much cold air and it falls on the floor, it's going to freeze up those areas. And so that's why it's huge how we manage the static pressure in that barn, so that we minimize the short circuiting, so that when the fans run, we're going to move that air into the barn at a high enough rate. Again, 800 to 1,000 feet per minute will jet that air into the barn further and get it tempered. And what'll happen, that air will want to circulate back toward the intake wall. If you smoke that air, it goes out. And because you've had this air rushing out, it's pulled air up the wall into that vortex. So you kind of create this low pressure, so that air will go out into the building and temper, and then some of it will curl back toward the inlet. So we're still kind of ventilating that area, but we're tempering that air and not letting it just come in and fall on the floor. And so if you're having trouble with freeze up, that's generally what's going on. Your air is coming in too slow. And I had a dairy out in the Dakotas or Western Iowa that he was going to put propane heaters on the end of his 900-foot long barn because he was freezing up his stalls on that end of the barn, close to 100 feet or better into his barn. And his vet called me and we had a discussion. I said, you got all the BTUs you need in that barn. It's just how you're using it. And so we looked at some strategies of one, he was using chimney fans in that part of the barn. And I said, turn those off because you're pulling your warm air out of here. And what we did is take his recirculating fans and tip them up. And we've done this in other dairies too. They've already got the fan there, tip them up so that fan would take that air down below, blow it against that baffle, and it would circle around in between those baffles and come back down. So we were purging some of that warmer, drier air above and heat back down to the cow level. So that was one part of the process. And the other, that he did some protection on that end of the barn by reducing the infiltration of air into the barn, like through the sidewall and doors and things like that, to tighten that barn up, and that solved his problem. So he really didn't need to go buy propane heaters to keep his barn warm. It's just repurposing what he already had in a better manner, solved his problem.
Perfect. Well, thank you so much, Dr. Wolf, for sharing all of your insights. If you would mind going ahead 2 slides. And we just want to thank everyone who joined us today. This is actually our last webinar of 2023. If you've joined any others this year, thank you. And if you like what you're hearing and want to listen more, we invite you to listen to our podcast. It's available on Apple Podcasts, Spotify, or wherever you stream your podcasts. It's called Dairy Intelligent. Very similar to this webinar format where we're having interviews with dairy industry experts on various topics. So we invite you to take a listen there. And with that, thank you again, Dr. Wolf, and thank you everyone who joined in, and have a great rest of your day.